started. All right, guys. On Friday, I kind of had you guys listen to, work, experience, whatever, that problem where you sort of came up with the shortcut, right? So, and so that shortcut can be very helpful to you, and that's what these notes are about today, is helping you to learn to do the shortcut. Your homework today, some of it is going to allow you to actually use that shortcut if you're comfortable with it. I'm not forcing you to use the shortcut. If you want to do it the long, regular way with the FOIL and everything, that's absolutely fine. I want you to do what you're comfortable with, but if you could practice the shortcut just a little bit during the notes, I think that you'll actually like it when you get done with it, and it will certainly save you a ton of time when doing some of these problems tonight on your assignment. First things, this is a typo. This should be 486. I don't know. I think it was a little dyslexic moment there. The homework page is correct, however. So here we go. There's basically two ways to work something that's a special problem. We have some special problems we're going to deal with today. You can rewrite the problem and then FOIL it, just like we did later in last week. First, outer, inner, last, or just the distributive property twice. But it's very specific. This shortcut works only on very specific types of problems, and they call those special products. And that's what we're dealing with today, is like special products. One of those special products is the square of a sum. Well, you have to understand the language, or you won't know what you're talking about. The square of a sum means I have two things that are added together, and then I want that quantity to be squared. Okay? Sum means to add. So the square of the sum. So if you see a problem that looks like this, which was just like our bell work this morning, you can, quote, FOIL it. Write it twice and do first, outer, inner, last. Okay? So, hang on. So, let's try to do that on this problem right here. Okay? Let's try to do it on the problem that we had. So we're going to write it twice. Then we're going to use the distributive property twice or FOIL it. So first times first is r times r, so we get an r squared, right? Then outer, r times 11 is 11r, good. And then 11 times r is 11r. And then 11 times 11 is 121. Adding like terms together, I have an 11r plus an 11r. That's going to make a 22r plus the 121, right? Okay, so this would be your first actual answer with the FOIL or the distributive property twice. Now let's imagine that shortcut. Do you remember at all what it was from last week? No? Not yet? Okay, well let's wait then. Let's wait a little bit since everybody's a little shaky on it. Let's go ahead and do the distributive property twice / FOIL on this one. How is this one different though than the one we just did? There's a couple things that are different about it. Two variables and there's a negative, okay? So instead of this being called the square of a sum, this is the sum part is that I'm adding a negative, okay? So it's kind of like a difference. And that's okay. We can still do it as long as it's only two things in here and that quantity is being squared. So let's write it twice and work it out. 3s minus the t times the 3s minus the t. So distributive property, first term times that gives me a 9s to the second power, because remember you're adding your exponents when you have bases that match. And then I have a 3st times a negative, a 3s times a negative t. That negative is attached to that variable right there. So that's a negative 3st. So that was the first term times both of those. Now I'm looking at the second term times both of them. So a negative t times a 3s is a negative 3st. And a negative times a negative makes a positive t to the second power, because I'm adding the exponents again. Combining like terms, 9s squared minus 6 STs plus a t squared. Was there anything that was similar on those two problems? Do you notice anything that happened? The two terms that are in the center of your problem are exactly the same. That's what allows us to build that shortcut that we were talking about on Friday. Remember how one of the things, I think it was like you had to times it by 2? You times it by 2 because you wind up getting 2 of the same thing in the problem. So let's do this one kind of with the shortcut. And then we're going to do 2 more with the shortcut down here, okay? So the shortcut says, and here are the directions actually for the shortcut. It says square the first term. Okay, so if I square the first term, I'm saying 5a times 5a. What would I be getting? 5 times 5 is
25a.
25,
25a
and
squared.
a times a is
A squared.
a squared. That's my first term. I now multiply the two terms together. So I have a 5a times a 3b. What's that going to be? 15ab. Okay, that would be my answer. But how many middle terms am I going to actually need? 2, and this is building the middle term, so I need to double it. So that just means times it by 2. So what's 15 times 2? 30. So I now have 30 things called AB because I needed to double them, right? And now square the last term. 3 times 3 is 9. B times B is B squared. You're done. That's your answer. So that's fairly quick as far as the shortcut goes. But that's how this middle term is built. Had I FOILed this the way I did all these others, I would have gotten plus 15ab plus 15ab and added those together to get to 30. Does that make sense? All right, let's try the shortcut on the first try it there. See if you can get it. And the notes are on the left-hand side. They're telling you exactly what to do. Who got it right?
Nope.
9s squared
How'd you get the
minus 6st plus t squared.
that's negative 6?
What did you get? Tell me what you got.
I got 9s to the second power minus 3st minus 3st plus t to the second.
Okay, right here it says multiply the two terms together. Now double it. You forgot to put 2 of them because remember if you did it long way, you would have 2 of the exact same things. So you need to multiply by 2. every time you're doing that middle term, squeeze them together with multiplication and then times it again by 2, and you get done. Okay?
Put them together.
You're
If they're the same thing.
Yeah, well, you're multiplying by 2. So what you got was the negative 3st, right? But you need 2 of them. So 2 times that will get you the negative 6 things called st. That makes sense? Okay, let's try the shortcut one more time on that last one. 7a plus 8b squared. So square the first one. 7 times 7 is going to be a 49. And a times a is a squared. Now multiply these two things together. So what is 7 times 8? 56. And what is a times b? AB. But how many of them do I need? 2 of them. So that's going to make your 112 AB. And now square the last term. 8 times 8 is 64, and b times b is b squared. It's significantly faster if you understand it. And the main thing is to remember to multiply by 2. Okay? You have any questions on that part? Okay. Real quick, I want you to just look at example 3. Just look at that. What do you notice? They're identical to each other. The terms are all the same, but the signs are opposite, right? What has happened in the past when we've had like a negative 4a and a positive 4a? What would happen to those two?
Cancel out.
They cancel out and become 0, right? That is what's going to happen when you have one of these special types of problems. This is called the product of a sum and a difference. A sum because these two are being added together, and a difference because they're being subtracted. That means the middle terms, instead of being added together, are going to wipe each other out, turn into a 0. And all you're going to have is the first term squared and the last term squared, but you will always have a minus sign in between the two answers. So let's kind of walk through the long version here so you can see what happens, okay? So 10a squared times 10a squared makes a 100a to the 4th. 10a squared times a negative 3. So 10 times a negative 3 makes a negative 30. A squared times b squared is a squared b squared. Right? Now we're looking at the middle terms here. 3b squared times 10a squared. 3 times 10 is now a positive 30. And it's still an a squared b squared. And then your last term, positive 3 times a negative 3 makes a negative 9. B squared times b squared makes b to the 4th. Notice that these guys are absolute opposites. They cancel each other out, and you're left basically with the first term and the last term, and that's it. So the shortcut on this one is really, really handy if you recognize it. Let's see if we can make it happen here using the shortcut. Then I'll do it the long ways to prove it to you, okay? So the shortcut here, we square the first term. So we square the first. So what would that be? 9x to the 4th. Very good. And we're going to square the last. And it doesn't matter whether you say the last in this set of parentheses or the last in both sets of parentheses, because they're the same values. The difference is the minus sign, so we don't care. So now we're going to square the last term. What's that going to turn into? The 36. And y times y is y squared. The rule is that you always use a negative. Okay? And this is called a difference of squares. And that's your answer. Was that pretty fast? For what looks like a big problem? This is what the problem would have looked like if you had done it with foiling or the distributive property the long way. I just want to prove it to you that this works. Okay? Okay? First times first, that's going to be a 9x to the 4th power. This times this gives me a positive 18x squared with a y. Middle terms, negative 6 times 3 is a negative 18 x squared y. And the last terms become a negative, because it's a negative 6 times a positive 6, 36 with a y squared. And as you can see, right here in the center, they wipe each other out. And you're left with 9x to the 4th minus 36y squared, which is exactly what we got when we did our shortcut. Just the secret to doing these well is really paying attention to what the original problems look like and make sure they fit the pattern before you do it. Okay? It only works for very, very specific problems. And you're going to have a lot of those specific problems today, so if you're comfortable, use the shortcut. Okay? Any questions? Seem okay? If you're not comfortable, do it the long way. Just get it right. I don't care. All right. Your assignment's on the top of the notes. I'm going to give you about half of the answers today out of the book. It's highly likely that you're going to need to take a picture of it up here because it's not very easy to read. I'm not even going to try to tell you it's easy to read because they're kind of small. But you're welcome to come up here and take a picture if you want to. Just to get you going, make sure you're on the right track. Okay? I'm going to hit pause here, guys. Don't take a picture right now. I'm going to get out of this. And you guys will